Good morning everyone, I am Priyanka Kulsundar, Assistant Professor IT Department. In my previous video we discussed about relational integrity and in this video we discuss about relational algebra. So first we discuss what is relational algebra. A procedural query language which takes input and procedure output in the form of instance of relation that is called as relational algebra. Relational algebra is nothing but the procedural query language which takes input and procedure output in the form of instance of relation. It's called as relational algebra. In this query execution is done with the help of operators. Query is done with the help of operator. An operator can be either unary or binary. Two types of operator, that is unary or binary. And relational algebra is the performed recursively on the relation, and intermediate results are also considered as that particular relations. These operations enable a user to specify basic retrieval request, or we can say that basic queries. The fundamental operations in the relational algebra are select, project, union, set difference, and Cartesian product and remain. The select, project, and rename operations are called as unary operation. Why it is unary operation? Because they operates on one relation, and the other three operations, that is union, and set difference, Cartesian products, on pair of relations. Therefore they called as a binary operations. Now first we discuss selection operation, or we can say that sigma. See in this diagram, this is sigma. The selection operator specify the tuples to retain through selection criteria. Now what is selection criteria? It is nothing but a Boolean combination using this in terms of forms. Then what is terms? Terms is nothing but the attribute of constant or attribute 1 of attribute 2. It means that these are the attributes. Okay. And what here it is a input. It is nothing but the relation instance. So what is nothing but the selection criteria? As the name suggests, selection. It selects the row that specify the given statement from the relation. This is a unary operator. This operation pulls the horizontal subset of the relation that fulfill the condition. This may be used operators like greater than equal to, less than equal to, and not equal to separate the data from the relation. It is also used logical operator like and, or, not to combine the various filtering conditions. This operation can be represented are as follows. See in this here, sigma of selection criteria with the help of input. So in this, sigma stand for selection predicts. Here sigma stand for selection predicts. Then R stands for relation. It means selection criteria or input stand for selection or relation. Then here selection criteria is nothing but the P. It is nothing but the propositional logic formula. It is nothing but the propositional logic formula. Suppose for example sigma category equal to electronics and in bracket input is store. So it will select the record. The output is that it will select the record from the store table of category electronics. It will select the record from the store table of category electronics and price. For example, price is 150. So this is the example of selection. Now the next type is that projection. This is also a unary operator like selection operator. The subset of relation based on the condition that specified is created by this operator. It considers only selected columns from the relation for vertical subset of that particular relation. It is denoted R as follows. So here is a pi, fields and input. So where pi is the symbol used for projection, this pi is the symbol used for projection, and here fields, or we can say that input. Input is nothing but the relation for the specified field. Relation for this specified field. Here column is A1, A2, A3 and so on are the columns of that relation which will display in the resultant subset. It means field is nothing but the column and input is nothing but the relation. So let's take one example. For example, pi fields is nothing but the student name, address and course, and input is nothing but the school. What happened in this case? It will select all the record from the school table. It will select all the record from the school table, but only for selected columns, that is student name, address and courses. If we want to select record for the particular student, then we have to use both selection as well as projection combination. Okay, in this case we have to use selection and projection combination. Next we discuss relational algebra operations set theory. In that these points are included. First one is union, second one is insertion, third one is set difference or minus, and fourth one is Cartesian product. Now we will discuss one by one. Union is a binary operation that is denoted by this symbol. The result of R union S is a relation that includes all tuples that are either in R or in S, or we can say that both R and S, and duplicated tuples that are to be eliminated in union. In this example, tables are two tables, person and professor. In person, SSN, name, address and hobby, and in professor, ID, name, office and phone number are not union compatible. Pi of name with the help of person and pi of name with the help of professor are union compatible. Next one, that is insertion. Insertion is denoted by this symbol. The result of the operation R with the insertion S is a relational that includes all tuples that are in both R and S. So the attribute names in the result will be the same as the attribute name in the R. The two operands relation R and S must be type compatible. Always remember, it must be type compatible. Now the next type is that set operation, or we can say that set difference. In that R minus S, it means that it returns a relation instance containing all tuples that occur in R but not in S. R and S must be union compatible. The schema of the result is the schema of R. It means that the difference operation generates a group of tuples which are present in first relation, that is R, but are not in the second relation, that is S. Present in first relation but are not present in second relation. It's nothing but the set difference. Now we discuss division operator. The division is a binary operation that is written by R divided by S. The result consists of the restriction of tuples in R to the attribute name unique to R. It means, for example, in the header of R but not in the header of S, for which it holds that all their combination with tuples in S are present in R. It is nothing but the division operation. Cartesian product operation. Cartesian product operation denoted by this symbol. It is also known as product or cross join, and its notation, that is R into S, combines tuple member of one relation to other relation. It means that combines information of two different relation into one. Here R in bracket A1 A2 up to the An into S B1 B2 up to the Bn. It means that the tuple that is A1 A2 An B1 B2 Bn. It is nothing but our Cartesian products. Next one is join. Join is used to combine related tuples from multiple relations. Here this is the symbol of join operator, and it is used to compound similar tuples from two relations into single longer tuples. Join operation is generally the cross product of two relations. The notation is used R join to S. It means that it is the simplest form. The join operator is nothing but the cross product of two relations. When join become more complex, the tuples are removed within the cross product to make the result of the join more meaningful. It means that join are used to evaluate the join condition between the attributes of the relation on which the join is operated. Here is the example of join for R, column A and column B. For column A's value and column B's value. So R join equal to R dot column A equal to S dot S column A. So here we generate the table. And for S of column A and S of column B, it means that R join R dot column B equal to S dot S of column B. So here we generate this table. Next we discuss types of join. There are two types of join, that is natural join and outer join. So what happened in natural join? The join involves an quality test and thus it often described as an equijoin. Such joins result in two attributes in resulting relation having exactly same value. It means that a natural join will remove the duplicated attributes. Natural join remove the duplicated attribute. In most systems, a natural join will require that the attribute have the same name to identify the attributes to be used in the join system. This may require renaming mechanism or renaming type. And if you have to use in natural join, make sure that the relation do not have two attributes with the same name. Okay, relation do not have two attributes with the same name. Now next one is outer join. Notice that much of data is lost when applying a join of two relations. In some cases, this lost data might hold useful information. In outer join, retains the information that will have been lost from the tables and replacing missing data with null values. So there are three different forms of outer join depending on which data is to be kept. So first one is left outer join, second one is right outer join, and third one is full outer join. What happened in left outer join? Keep the data from the left hand side. In right outer join, keep the data from right hand table, and in full outer join, keep the data from both the tables. These are the example of left and right outer join. So in left outer join, keep the data from left hand side table. Keep the data from left hand side table. It means R column A column B. For R left outer join, R dot column A, it means R dot this column A equal to S dot S of column A. So for this S of column A. So for as it is same for S, it means that keep the data from left hand side, and for right outer join, keep the data from right hand side. It means that keep the data from right hand join tables. Now this is the example of full outer join. It means that keep the record from both the tables. It means that for left hand side and for right hand side, keep the data from both the tables. Okay. So in this video we discuss about two operator, that is unary and binary operator, in that selection, projection, then insertion, join, then also we discuss set difference, then division operator, and also we discuss Cartesian product and join operation perform, in that left outer join, right outer join, and full outer join. And there are two types of join, natural join and outer join. This all concept we are discussed in this video. Thank you so much for watching this video.